Yeah, I guess it's
Oh,
start recording now.
okay, then now I will continue continuously. Then I just explain what we did from last Sunday, where we have uh, for now one, two, three, four methods. The first method is before A1, where we check if the palette is empty or not. And if it's empty, this will move the palette inside the A1. And the other condition is if all of the jobs are done in for the workpiece on the palette or not. If it's also done, it should move to the A1 for unlock and reload the new workpiece. To
Honey,
do,
can you say the string?
sorry, uh, yeah, thank you. Share my screen. Okay, and then to do that, um, I have the function uh, load. Okay, so the load here have me load and unload the workpiece. So here I just check. So it is empty. So I take the subpath, move it to the palette. Okay. Why I can do it from the subpath? Because I do it here at the -1 with the interval of 0. This means that there is always NU that waiting here for me to pick up to put it on the palette. Okay. If you don't set up in that way, and then maybe here you also need to wait until, remember, just like the exercise, wait until, what? Through half, through half dot occupy, okay? But because I set up in the support, the behavior that there will be always and for me to pick up. So that's the reason why I don't really need this one. Okay. Here is for unlock. Unlock is mean another way around. So also the command move. But in this case, move from the app.com to the RAM. Okay. And here it just repeat here for the uh, that's been after you unlock, you reward it with the unlock. And then we have the before A2. So before A2, we check two conditions. The first one is drop A2 is done or not. And the second condition is there is enough place inside the station A2. And if it's yeah, not yet then A2, and there is enough place inside, this will move to the you know, station A2. The cost here, the meaning short, it means successor, it means the object connect to to uh, this means here you have the question mark, the one connect next to the question mark. So it's here I connect my method here. Sorry, I connect my method here. So before A2 and here the method before A2 is connect here and the object that connected next to this one is this and this. Okay, the A2 and number two indicate that I want to reference to this object. Okay. Then here, the reason why I'll say question mark dot succeed, and then in the bracket is number 2. Okay, this is before A2. And inside the process A2, I just put the activity of the workpiece from false to true, because after the process, this means indicate that the workpiece already done the process A2. So this is where I connect my method A2 exit of the A2A, as well as exit of the A2B. Also the exit of A2C. Okay. Questions so far? So if not, so I will continue with the role of the simulation. Uh, so I will start the simulation. So nothing first means go up, that's new part. Go out, and then the A2, and then go here. Uh, which go out, this is to go move here because already done. Okay, so here go. Okay, go here, and then before I3, this is what I need to do next. Now I cut here, uh, before I3, before I3. So what I will do with this page? Vertical. So here, A3 is the same. I think that if you know how to do it with before A2 or before A3 is more or less the same. The difference here is we check A3 and we check the successor here to make sure that it's also connected here. Because if you want to use the success, and then you need to connect them with the this is up here. This is 2 and this is 1. And we put the 2 go here. And this is with this here. Yes, correct. And move to the successor 2. Yeah, that's it. So this means what I need to change is one click here. Okay, yes. So then after that, I also need the method here, A3. So we got A3, I3, I3. Okay, I have the station H3, so I cannot have the same name for the same object. So I will say this is uh, A3, station H3. Okay, and then inside the station A3. So what I do is just the same as the A2. Okay, so just put here instead of A3 equal to 2, so A3 equal to 2. That's it. Okay, figure. Connect before here, before A3, and now machine here, entrance, no, exit. After we finish the, the process, we put it here, finish as the here to make sure that the path go out and then continue flow here, make the connection from, from here to here. And from this is a bit in this direction. And yeah, so run the simulation and check. For example, here, this is true. So I make it false, for example, and then it will go inside the A to B again. Okay, okay. I cannot put it over here, otherwise it will not go out. Okay, it for example, phone. After that, it will go to the A to B again. But now when it's not done, the A3, it will go here to A3, and when complete here, you see A2 and A3 is correct. Next, you see that here is the third, so I will rely another method. Here is before A4. Okay, that is the same, but here is A4, and then so correct here. Okay, okay, from here to this, and here I have also the another method, uh, station A4. Oh, it's for order is also the same. We just put here. So for and it's exit. Okay, put it here because I brought the contact only outside of the station. Okay, and Wi-Fi is the same. So just need to duplicate here. Okay, Wi-Fi. Okay, Wi-Fi done. For Wi-Fi, here is the same. Here, Wi-Fi. Okay, for Wi-Fi and connected here. Okay, and here is the same as it. Select option. Wi-Fi done. Here. Okay. And until we have the contact A6. A6 is a little bit different where we need to check all of the uh, A3, A4, and A5. Okay, but it's not that typical. So what we need to do is here. Okay, phones. First, let's do it like this. Check if this is a place or not. So if it's a place, we check another thing. A all 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 three. Okay, what is okay? Speed clearer. Uh, Okay, this is the first thing I check. Check if enough place. Okay, if it's enough place, then if we check what to check, check for the workpiece. If there is one of A3, A4, and A5, either one of these holes, if we go to the process A6, okay, otherwise it will continue forward, okay, and of course, if the first condition is not correct, it means that no place to go in, and then there is no need to check uh, about the system or not. Even if you are not done, but there is not enough place for you to go in, we don't really need to check this one, but we can put it into if condition separate inside. So first check this. This is enough place, and then we will check if necessary to go in there. Okay? And that's it. Say we need to connect. Uh, in that we need to specify when we need to call the method. Here we call it here before the patient was 6. And inside here, uh, we don't say A6 done, but we will call it on done. Okay, and method on done will make all of the A3, A4, and then I5 equal to true. And then if you don't want to connect it here, you just say add document. Okay, and now connect it here. That's it. Object on done. I still leave it front because I already write in the code that add move. This means that after it's run the method, it will run the move, and then I don't really need to put the option in. Okay. So either way, if you don't write the code, and then you need to connect the code at the exit and put it here. If you write inside here, okay, so I will show you the difference. Just again, five done on the window protocol, and you see after set the attribute of the workpiece equal to true, and then here in the A5 I say nothing. So it means that the code will stop at this moment, and this will remove the object and you that we want to go out of the station. Okay, because it stopped at this line. It means no more action. Okay, and for that reason, if we want to the simulation continue run, this means that the MU should be located outside of the station, so it's touching the the connector, and because it's touching the connector, it's know that they need to flow continue going to the next object. And here, when I don't let the MU touching the connector, it means that it remain inside the station. But because the code tell that the F dot move, it means that it's moved to the next one. Okay. And now we just finalize our simulation model from here to here, from here to here, and to here. It's already is it? Yes, it's already there. Yeah, it's already there. Good. Okay. And now we can uh, run our simulation model for one pieces, step by step. Load path, get out, go here, and after that, you see the phone of the is true. Those means this will not go here. Okay. On of the process is true. This means that it will go here for unlock. Go to I1 for unlock, and then here is the one that's already unlocked, and here is missing. This means that it's already taken by the palette. Okay, and continue, and in the 2 seconds, 2 seconds. Okay, for example, so I will let one of the uh, process here a false. So it's been I3 now a false. So it's we should go to I6. Okay, and after roll out from I6, Uh, okay, so about to come. Yes. So on done. Or just let it do another round. Uh, no, this one. Okay, solution. See how long does it take for one uh, palette or one circle? So to do that, I set here only one for each and reset. Okay, so it's around 450 seconds. Here, the message is cannot upload new because we supposed to load the new one. Okay, we supposed to load the new uh, material in here, but here there is no more material. That's the reason why it put up here because it is for okay. Shootpark.com is contained inside the Shootpark evolve. Of course, it is void. There's nothing here because I only allow one what is here to collect the data. This means that it takes 4 minutes and 52 seconds for one pallet go one round. Okay, and to compare it with the calculation, you will check this is the correct simulation model or not. Okay, is anyone already calculated by here? How long does it take for one pallet go one circle inside the simulation system? So, okay, I have the request that do the A6 before A6 again. Before A6 here. So this is a method before A6. So maybe one more line here, one more line here. So this is a first if. This is check whether A5, A4, or A3 is not the process. It's because, and then if it's one of this condition is true, it will jump in to make this one. And this is nothing else than move the palette, admin palette, because it's the end use that trigger this method. And this is the destination. The destination here indicates that it will move to the station that store or contain this method. Okay, and because I connect is here, so the question mark means the A5, A6, and the object next to it on the two connector, connector number two is this XX6. Okay, so this is the before A6. Okay, F7, multiple, this one. And on the right hand side is the method A6. After go inside the A6 station, on of the drop from A3, A4, A5 will become true. Okay. And then here you will see this is the approach from your colleague. So we check if uh, the content of the palette is in the part A3 equal to false, and A6 buffer less the A6 num value. What is A6? What's the object A6? Uh, what is A6? So if your A6 is here, is correct, but the station is not correct. We want to check the num MU of the conveyor before the station. So in your case of Mr. V, your code will be correct if you check the num MU of this object is in the conveyor before A6. Okay, not the A6 itself, but the conveyor before it. Okay. So you need to check the B2A6 dot num mu less than 2, not the A6, because A6 is a machine. The num mu of A6 always 1. Okay. Then let Mr. Da also share his screen. Then you will see it's another approach. Yes, Mr. Da, you can share your screen now, and then we will see the problem. Okay, so we wait for you later, and then maybe I will also save this and save it and send it to you. Okay, so I will send now this simulation model approach to all of you. Then you can have one on the computer to run, try out. Um, this one.
Sorry, Mr. Dick.
Yes.
I have a question. So, how could we? I means when the move unit, the MU car goes to the station number 6. Assume that it skip station number 5, right? And how can we capture the processing time of the fifth, the number 5 station, and set the station number 6 to run exact the same time?
Okay, I get it. Yeah, I get your question. Thank you, Mr. Phúc. Yeah, so as mentioned, process A6. Let me share my screen again. Let me share screen here. Okay, so now about the processing time of A6. Uh, as informed, the processing time of A6 is 20 minutes, 20 seconds, right? And then for your assumption that you assume that for every missing process It will take 20 seconds. Okay, so we can do it like this. Okay, this is after, and then we need to have another method, and this method we call A6 beating just in time. And of course, it will connect at the entrance and before action. Okay, and then here, what we write here, we want to check this project with dot on. This means that the MU inside of the palette A3 equal. When you want to check, this means that you don't need two dot equal, but just equal. And I will do another approach. Bar I is an integer. Okay. And then if point, then I will set I equal 1. And if the same here, okay, but now for I equal to I plus 1. And so this means that if the A3 is not finished, this means if you set the value of I equal to 1 and fail any other process, this means A4 and A5. If it's false, it will increase the value of I by 1. And then finally, I will set the A6 dot block time equal to I multiplied by 20. Okay, it means that if one process, so maybe here, sets the initial value of I equal to 0. So it means if for only 4, A4 is unfinished, and then 0 plus 1 equal to 1, A5 is unfinished. It means plus, no, doesn't plus 1, and then it's become only 1. 1 multiplied by 20 is 20. Okay, so this is how we can set the processing time according to how many processing input.
But in the exercise, is that I thought that the operation time of the ISIC is 30 seconds.
30, sorry, 30 seconds. Okay, and then 30. Sorry, I didn't remember that. Yeah, so 30 seconds. And then for each missing job, this will add up for 30 seconds. Okay, and of course, I remember that I also explained to someone else that there is another approach. This means that there is more than one way to do the same thing. We can do it in the way that okay, so we will if add dot on is in the same thing, we check the workpiece inside the palette and we check the attribute. Okay, So this is pause. Then this means that we wait for a second. Then we have another if s dot com dot a4 points. We will wait another 30 seconds. And again dot com dot a5 we wait 3 seconds and and okay.
Sorry.
So, yes.
For this method, if the condition of the A3 is true, it will end the
Wait.
if and go out immediately, not wait.
It
mean, if
will-
it only check the condition A3, if it's false, it will go into the if, but if it's true, it will go out and end the method immediately.
Yeah, correct. That means this is pause, and then it will wait, and then it will wait for 30 seconds, and then we will end here. Okay, and then we will have here separate like this. Yeah, thank you, Mr. Huy. Yeah, so this is where to have 3 times. So we check for each condition. If it false, wait 30 seconds. If false, wait for 30 seconds. If it's true, it will skip the 30 seconds. Okay, so this is another way that you can have the different processing time for for the X6. Okay, so it can be 30, 60, or in total 1 minute and 30 seconds. Okay, and we will send this. Before I send the file, so maybe we also do the simulation of several pallets. For example, here I have 20 pallets. Okay, let's run the simulation model. Sorry, forgot. So this is infinity. Infinity. To have the analysis of the system, you need the user interface chart here, and you can put the uh, the on of the station in here, and you can see the start rate. For example, I put here A1, and I will see the statistic of the A1. Green has been working. This color is brown is setting up. Of course, we don't have setting up. We don't wait. The gray is been waiting. The yellow is blocked. We don't have the power up or down. We don't have the fail. We don't have the stop. We don't have the hold. We don't have the unblock. So technically, we have three main color. Be here, the green, the yellow, and the red. Okay. Then A2 is mean that most of the time it's working. to B, to C. And by this way, we remember when we study the learning factory exercises, this kind of graphic help you find the bottleneck and the balancing of the system. Here, you can see, so I will speed up the simulation model. And we will see that they will, okay, included here, count. Okay, this is a kind of statistic tools that you can use. So let me run the simulation model with Foley palette. Okay, at the beginning, because a lot of empty palette go in A1, so that's the reason why A1 is working on at the time. Now, when all of the palettes is have the workpiece and go to other, A1 have less work, only that unlock. Also do it with 60 palette. As I already explained to you at the beginning, our system have one problem that they have the buffer here is not correct. The length here is 0.2 meter. This can only store maximum 4 pallets. Okay. And here, when we run the simulation, we will see that, okay, not 4, but they can queue up 3, 4, 5, 6. So it's not correct. Okay. So this is the misunderstood of the system because they always taking account the palette before the lot after that. Okay, with the length of 2 meters, the maximum palette that you can store is only 4. So maybe we can put here. Sorry. Maximum is here is 4. So let's check this graph. Yeah, so it's only 4 is allowed, and here is the same with the length of 0.8, the maximum is 2. So we can classify here 2. And this is 2. This here 2. So this here 2. 2. So if you don't set this, so it will be 3 pallets will be located on this container with the length of only 0.8. 2. Okay, so now we can run the simulation again. Okay, so because of we have a lot too many pallets, so it means that they happen the block. Okay, okay, it means that they got stuck. Okay, and the simulation will stop at 80 minutes. Yeah, after 80 minutes, the system got stuck. Okay, and here we can run the simulation in 1 day. Okay, and we start the statistic after 2 hours. Okay, yeah, sorry, the number of pilots here is 40, and then we will see that we can run the system. So this is sorry, and then for the simulation start. 1 day the statistic after 2 hours. Okay, yeah, right. So this is 11 day. 1 day. This is 1 day. This is minute. This is second, minute, hour. 1 day. Yeah. One second. Work like once for so many times, so many days. This is hour. Yeah, this is 1 day. Well, correct. So here is the final result. This means that working all of the uh, capacity, and the one is only around 30 less working time. Okay, so this is a field of the capacity and how to find the optimal number of the pallet. You need to do the experiment manager. So if you don't have this one, you need to do it by hand. By, for example, you start with this one pallet and rather than let's say only 8 hours. So what the first that is hour. This unit is 6 hour, and then the information I have the user interface this one. Okay, simulation model. And after 8 hours, I have 61 products. And then I increase this two, and then after 8 hours, I have 122. And I'll keep doing this. For example, I have 60 pallets, and I have the simulation got stuck. Okay, and you have to review it by 59, and then you will see after 2 hours it got stuck in 0. This means that it's not always that increase the number of pallets will give you the maximum number of throughput. You need to find the optimum number of pallets. How to do it with Experience Manager? Actually, you can do it with code, but here is a tool for you to do it. You go to the advanced settings and you say rules, use rules, and then you will add your own rule by clicking here. Okay. And then you will action and in the action, what you will do is you will increase the sheet palette. Okay, you will increase the sub palette by 1. So what is the attribute of it? Then just give me a number. Here, the number. And then so I know this is an attribute that I need to try to increase the number of pallets. Where is it? Here, number. Okay, so pallet dot number. Okay, equal to itself plus 1. Okay, then that's it. So this means that for every new run, it will increase the number of pallets by 1. Okay, so how many will do it with 60 times? This means that this will run the simulation with 1 pallet, 2 pallet, 3 pallet, 4 pallet, and so on until 60 pallets. Okay, then okay, that's it. Which one? Okay, of course, I also need to find the output is the RAM dot static memory that we already know. Num okay, and then now we set, and don't forget to put here 0 set and start. Sorry, reset. We don't need to run the simulation model many times. We just run it one time because there is no random number here. Okay, and here is my report. Oh, sorry. I forgot to put here. One. One, two, three. Yeah, I put here and reset. And then if it's correct, and then the number of palette here should be okay. So it's something wrong. Model and cut action. Here. That's correct. If it's good, just do it like this is. So this is from drag and drop. It's reference to this. So that we sorry, I forgot to save the method. And then now we reset, we run the simulation. And then if it's correct, this one should be 60. This one. That tool is actually used for first simulation. Turn on of the simulation. Here is one. Okay, reset. That's the one. I like this one. Okay, then reset. Right. Okay, skip running. This means that for every time it will increase the number of palette by one. Okay, so here is the screen 40. This means that the palette will be 40. Install. Okay, so it's just to have the simulation run for each time that it run the simulation, it will increase the number of palette by changing the attribute of the sub palette by one. Right? You can do it with Experiment Manager, or you just simply write nsim for it. Okay, it's 50, 51, 52, 53, 54, 55, okay, then it takes me 126 seconds. Even on 60, and this is the result that I have here. So this is from the version 33, 32. So that's the reason why this doesn't look nice. So if you have the 3201, so the process will be nicer. But anyway, so uh, I will put here on the page. With my pen, I will highlight the results so you can see it more clearer. So this one, this one. So at the 0, so I have here, it increased to here. And then it's stable. Let's go here. It drops. Okay. So the maximum that I have with the minimum the maximum throughput with the minimum pallet I have here around 24. This means 24 pallet. Okay, and I have the throughput around 5. Is it? So this means 557. 500. Ongoing, I will do it again. So here, 0. This means 0 pallet, 0 throughput. 1 pallet, I have 54. And then here increasing. This will remain the same. Increasing here. I have the top here. Okay, it got stuck. And I have a top here. Go down here. And if I keep going and until here, I have the throughput suddenly drop because it got completely stuck. Okay, so that this is my optimum. Okay. So questions? So this is to analysis tool that you can use for analyze the system. The first one is the chart here. The chart you can find in the user interface. Okay. And the second one is the experiment manager to have you run several simulation with slightly change in your setup. Okay, for example, the number of pallet, the number of processing time, whatever that you want to update for the next simulation run, you can write inside the rule. Okay, we'll show it again here. So this is where you can do the result statistic. Of course, there is several things that you can have. For example, you have another chart, and in this type of chart, you can show not only the statistic response about the occupancy, for example, rather than checking the okay. I will pick the occupancy here to see how many products that is in here in this profile. And also here, for example. And then when I run the simulation, so first of all, 24 is optimal. Okay. I will see that, okay, this is 90% that I have 2 MU in the buffer, and less than 10% of the time that I will have 1 MU. And there is no chance that I have 0 MU in this buffer. Okay, so you can analyze on other buffer to see what is the width inside the system. Okay, so this is where you can have the statistic in the chart. And then experience manager, so it's help you run not only one simulation model several times for the random event, but also have you run many experiments with slightly change in the parameters. How to do it? You go to the tools and then go to advanced setting, rules, create your new rules, and do it with the method action. You can do it with method condition, where you check the condition is true or not, and then it's not, and then it's run another simulation. This is false, and it stop the simulation. But here, in this case, so we want to update the parameter every time we run the simulation. We use method action, and what you want to change after one simulation, one experiment, you can write it. Okay, for example, in the second simulation, you want to change the processing time of A6. For example, you just write here equal to, sorry, okay, multiplied by the time of the experiment. Also, for example, you can set this I equal to 0. And after the simulation, you increase the number of I by 1. This means that for every time that you run a simulation model, you increase the processor by 6 by 1. Okay, again, so this is where you can update some of the uh, attribute of the object inside your simulation, and you ask them to run 60 experiments. For each experiment, the difference is in what you wrote inside this method. Okay, there is an exercise just exactly the same about this. I think that it will be on exercise 50 or 51, where you take the assembly of the frame of painting shop and also find the optimum number of the hanger. Okay, you can find that exercise in the guided strip. Okay, questions? So in meanwhile, I will save this simulation and send it to you. So if you have questions, so now the time and answer the question about the project that you will work for evaluation. For example, okay, send it to you now. You can find the simulation model now in the chat box. Yeah, until it's finished uploading. Yes, it's finished. You could find the flexible assembly line, the simulation model file in the chat box. If your chat box. Questions? Um, So let me do this exercise. That is perfect. Then set the dot. Okay. Okay. So if you cannot do anything in any step, you can share your screen and if you will solve the issue. Yeah. Yeah. Objects.
Uh, can I ask some?
Yeah, sure.
The part in my A6 station, the A3, A4, A5 is already through, but why still going to the A6 station?
Okay. Can you share your screen, please?
Can you see my screen now?
Yes. Do you have the simulation run of it? Yes. Okay. Here.
Okay.
So you have here.
Like here.
Okay. So A6 is not the job. So we only have A2, A3, A4, A5. A6 is a station that can substitute for the A3, A4, and A5. So technically,
Yeah.
we only have the job A3, A4, A5, not A6.
I will delete it.
Okay. And then you have the A5 is false, right?
No,
So
3,
after
4, 5 is all on through,
also on through, okay.
but it's still going to A6.
Okay. So it's happened in our simulation model.
Yeah.
Okay, you check again.
So what should I check?
So you can help me with the F9, FD before A6.
F9 of A6.
Yes, F9. I'll open the method before A6.
Oh, A6.
Yes, and press F9 here.
F9.
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 So, yep, F9 at the beginning. At the beginning, yes, F9, yes, correct. Thank you. And then run the simulation model, please. Reset and run the simulation model.
Now run.
Yep. And then it will stop here. And then can you go to the tab, the debug window, go to anonymous identifier, debug window. Yes, and then we check. So the container number 1 is our add. The question mark is the A5, A6. Okay. And then now if we check the A content, so can you double click on the MU inside the container? So all is true, correct, because the first part, and then can you move your mouse to the so I will show you. Can you make your mouse here? Can you see my mouse?
No.
Mhm. And so
Okay.
when you move your mouse here,
Uh,
can you see?
uh,
Can you just-
the red, right?
Yeah. So can you go back to the simulation model? Yes. And yep, you just point your mouse there. Yeah. No, go to the simulation model, please.
Okay.
And just lift your mouse there. No, in the equal. Okay. So and how about go in the num_mu? So it's equal to 0. Let's say it's true. So this is an N. Okay. Press F11, please.
F11.
Okay. F11 is mean that it will skip the move. Okay. It will skip this one and jump to here. And it will check. And then if this F11 once again, let's go here, correct. And then F11 again. Okay, I get it. Yeah, I know what is the problem of it. Because you have here F.move. So it will move. Okay. And then because that we have the connector here and the connector here, so it will randomly choose between these two directions. It can move here, can move here. Okay. So it means that if you cannot write here, or maybe I also make the same mistake, that because we have the connector, so after this object, the MU can go both of the direction. Sometimes it go here, sometimes it go here. Okay, because there is connector. And here it just say move, which means go forward. And this is only correct when we write in this way. It means that there is one way to go. Okay, and then we write f.move is okay. But here we have more than one connector.
So I should
Okay, that's the reason
I should write.
we need to specify with the bracket about the destination. This means go to this object.
Move like this.
Yep. Close your bracket, please. Yeah, that's it.
Now I run again.
Yes, you can run again.
Okay.
Yeah, and then also delete the F9. So press F9 once again at the beginning of your code. Yes.
Can you say again?
At the beginning, press F9 again to deactivate the bracket point. Yes. Okay, now close it. Close the window. And then save the method. Okay. That's it. And now you can run the simulation model. We make the connector. I make the connector for the system to understand what is the successor and predecessor of the objects. But maybe you don't really need to have the connector from here to here. You don't need this one because you write directly the same. You don't use question mark a lot or add a lot or add dot or question mark dot succeed. So maybe you don't really need this connector to use the system. Okay. Okay, you run the simulation. So maybe I also make the same mistake that
Okay, simulate is right.
it's still run inside the A6.
No, but the throughput is better now. Before it's only 1022,
Okay.
1022. But now on the value is phones on or one of it is phone.
Okay. Okay. Thank you. Yeah. So I think it's the course is correct now.
Okay,
And
thank
yep.
you.
Surely let me know if I'm having the same mistake as Mr. Phúc. Yeah, so here, yeah, I have the same mistake. So when I write add move, so I need to specify the location here. So Mr. Phúc, can you, okay, so thank you. So let me share my screen. So I have the same mistake as Mr. Phúc. Okay, and this is realize that. So here at the end, so I need to specify the location of the A6. So otherwise we send to the either here or either here. Okay. So here before A6, so it's we send to A6 B1. One. Okay. And how about the other? Yeah, here. Before A5, this means A5 B1. Before A4, so here the same A4 B1. Now, B2 is the same A2 B1. So previously I didn't connect this one. Okay, I don't use this connector, and because that I want to use the method A2 before A2 for for all the A2. So that's the reason why I need to specify here, move here, move question mark dot succeed. Okay, and this is number one. Here, so you can understand. So I connect my before A2 here and also here. And rather than write two methods, I only write one before A2. I connect it in two places. That's the reason why I need to more to be general in my writing my method. So I write with the successor function, and the successor has two successor. Successor number one is mean go forward, go straight forward, and successor number two is mean go up to the x. Okay, and this is the condition. If false, it means that A2 is not done. There is enough place to go to the A2. If we go to the successor A2, otherwise if we go to the first successor, this will go straight. Okay, so this is the correct method. And should I run that one? Here. and show the graph. All the three is working. So what is the problem? So I find it. So this only one. And we check it again. So go here, log. And this one. So it's not here. I see here. F check. And the problem on storage is correct. And then and you here. So we move this one. And this will go up. F11. Okay. Okay, got it. And this will go up. And this will be else. And then it's here. Okay, correct now. F9 remove over here. And this will down. It go in. Otherwise, here is else. And don't move. Let's go on 3, 3, 1. Now here. So it means that if the condition is correct, it's go up. If not, it's go straight. Okay. And here the same. So if it's correct, it's move up. And here is the elif. And here is N. And for one is the same. If the condition is correct, go up to the successful school. Otherwise, go straight in here. And I click. Okay. This is it will be in here. This is the check this one correct. And then if it's not, if it's L, so in here, sure that we touch the connector. Mm, okay, it's good. Okay, so this means that we have on of the case is covered by the method. So we will now one and repeat on. Okay, go here. Skip the other A2, go to A3, then A4, and then go to A5, skip the A6, go to A1, then reload, unload and reload, and so on. So now I will increase here to 24. You see, this is capacity. Okay, so the A2Cs doesn't work. Uh, doesn't not work well here because the capacity of the A2B is still have some capacity here. So that's the reason why we have the full empty of the A2C because the A2B is not yet with their capacity. This means that this is not in use. Okay, so and then we can run the 60 times the experiment with 1, 2, 3, 4, and 5 palette to see what is the maximum throughput that we can have. So here we can have more palette and we can have the third A2 which one. So because the palette is not enough to use the A2C. So you can see here. So after the certain time, the A2B is in around 30% of the utilization, and the A2C is not yet. So just a little bit amount because just in the on the first time when this is for the first order because we have the first A2 on up 3 pallet and then 3 pallet to A2B and the third A2C they can have only three the first 3 pallet and then after that will be covered by the two first A2 until the A2B reach 100% capacity. Then you will have the increasing in the capacity of A2C. Okay, it means that the number of pallets here, the 30 is not yet utilize the capacity of A2B. Okay, keep increasing. We see five. Okay, still don't have. So there is something wrong with the simulation model. So let me check. So, I see. Okay, so if you go here and do on the process. Okay. Okay, do you have any questions?
Questions?
Have no question.
Again, so if you have no question, you can leave the meeting. So if you still have problem with the simulation model, so I can help you with the code and the setup of the simulation model. And please don't forget to inform me about your team member, the member that you will work in your projects. And if you have the projects from your own idea, so please send it in the format of the just like what I did with the project description. So where you have the few line about your system and you have some remark, then what is the data that you use, and then some questions you want to answer through the simulation. For example, find the optimal number of pallet, find the throughput, find the optimal number of worker, and so on. Okay, so if you have no more questions, so we will meet again on Saturday. So this meeting, Saturday, tomorrow, I will send it to you via email. Miss Lee, can you stop the recording? I think that this is big enough, the file big enough.
Yeah,
So
sure.
otherwise you cannot upload it
Yes.
to the Moodle.